Alright, last two problems in this section are kind of leading us into the last big idea that we do this semester as far as normal distributions go, and that's an idea called the distribution of the sample mean and the distribution of the sample proportion. So in this problem, number 19, number 20, notice the wording, how the wording here changes from part A to part B. So we get to assume that heights of women are normally distributed. Mean is 63.2 inches. Standard deviation 2.6 inches. Alright, one woman is randomly selected. We want to find the probability her heights between or is less than 64 inches. Alright, now this is a little drawing here. If I were to shrink this down a little bit so I can bring it in here. If I were to put in this information on here, alright, less than 64 inches, that means 63 inches. So I'm going to draw this is going to be over to this side. Alright, so this is 63.2 inches, and this is 64 inches. Let's shrink that down a little bit. Alright, that's what these two numbers mean, okay? I'm going to go ahead and pour this in here to show the shading. So that's what we're looking for on this problem. Below 64 inches. Okay. This is in the original distribution of the population. Okay, so that's what we're being asked to find. The calculator will do it. It's again, we're finding probability, so that's normal CDF's job. So normal CDF, where does this shading start? This shading starts way down here somewhere. Alright, some really number that's really far away from the mean. So again, you can just use a bunch of 9s if you want to. Alright, where does the shading end? The shading ends right here at 64. Alright, and then the mean, back to the original, the mean is 63.2 inches. And the standard deviation is 2.6 inches. Alright, so that probability, 0.6208, is the probability in this distribution, heights of females, that we select one randomly selected female. Alright, now, completely different wording here in the second one. 41 women are randomly selected. Find the probability that they have a mean height less than 64 inches. Alright, find the probability this mean, this average of these 41 women's height is less than 64 inches. Alright, now, it starts off almost identical. We go to the normal CDF because we're still finding probability. Alright, this is still randomly, this is still normally distributed. So less than 64, so we're starting off the same way. Some number that's far away. Where the shading stops. Alright, the shading still, this is almost identical here. The only thing that's different here is not the mean. The mean's still 63.2 in the distribution of all these possible sample means. The only thing that's different here is the standard deviation, and the standard deviation gets adjusted 2.6 divided by the square root of the sample size of this 41. So that's where this number goes. Alright, and then we hit enter. So 0.9756 to 4 decimal places. Alright, I'm going to do a similar one so we can get the idea down. Alright, I'm just going to go through it with the calculator here, not go through the drawing. Alright, one woman's randomly selected. We want to find the probability her height is less than 64. So this time, less than 64. So just like before, we have a big number of deviations away. Alright, the shading stops at 64. Okay, the mean is 63.5. The standard deviation is 2.9. This time we do not have to adjust it. Alright, it's just a single woman randomly selected. She's in this data set, so we randomly select her, and there's the probability. She's less than 64 inches. So 0.5684. 56. Yes. Alright, now second one, 37 women are randomly selected. We want to find the probability they have a mean height less than that. So once again, this time, same area that we're looking for, less than 64 inches. So negative 9999 stops at 64. The mean height is still 63 and a half, just the way it was in the original distribution. But now our standard deviation is the original standard deviation divided by the square root of the sample size of 37. Alright, and then there's our number, 0.8529. Alright, so remember, the difference between these two is the first one, you do not adjust the standard deviation if you're dealing with somebody from the data set. Alright, somebody who meets these qualifications, meets, somebody that belongs to this data set. If we're randomly picking just one of those, then it's just mean standard deviation here. But if we're taking a sample of some certain number, and then we're looking at the probability that the mean of that sample falls in some region, now we do have to adjust that standard deviation, but nothing else changes. The mean doesn't change. The region itself doesn't change, just the standard deviation. Okay, so make sure that you understand that. This one, the probability we're looking for involves a mean of a sample. Right, this one, the probability doesn't. It involves one person from the population.